Okay, so section 7.2, trigonometric integrals, okay? This section I told you guys is an important section, okay? The entire chapter 7 is important because we will learn different kinds of the methods about how to do integrals, okay? So this section is involved about what? Trig functions, okay, trig functions. And this is what we did last time, okay? For the 6 basic trig functions, what are their derivatives, and correspondingly, what is the corresponding integrals, okay? So for the sine and the cosine, okay, you should know that, oh, the antiderivative for cosine is sine function, antiderivative is net cosine, okay? Well, for today, okay, we don't have time to review about these, okay? Yeah, this type of integrals, okay? You can review by yourself later. So today, we're gonna finish learning the integrals involving tangent and secant, okay? Involving tangent and secant, okay? So I need you guys to be familiar with these 4 integrals, okay? Before we look at the specific questions in that part, okay? So I need you to know that, okay? When we have a secant x square, the antiderivative is what? Tangent x. Remember this, okay? Later, oh, we may have, ended at a step, a line with, oh, what is secant x squared? What is antiderivative? You know, it's tangent x, okay? Cosecant x squared, antiderivative is negative cotangent, okay? And when we have a tangent times secant, okay, so this is a dx, okay, I skipped the dx, okay? All right, so antiderivative is what? Secant x. Cotangent times cosecant, and the derivative is negative cosecant x. I need you guys to be very familiar with these integrals. You have to know this, okay? You have to know this. And then, okay, for the tangent and the secant, okay, you also have to know this identity, okay? What identity? Secant x squared equals 1 plus what? Tangent x. We have to know this, okay? We have to know that, okay? Yeah, we talked about this last time about secant x and tangent x, the relationship, okay? Also, we know tangent x, cotangent x relationship with sine and cosine, and especially these two, okay, secant x equals 1 over cosine, cosecant x equals 1 over sine. We have to know these, okay? And not only in this section 7.2, but also in the next section 7.3, we'll also have to know these basic trig identities. We have to know this, okay? All right, so except for those 4 integrals we just mentioned. Oh, what is the integral of secant x squared? It is tangent x, blah, blah. We also have to know the integral of these 2, okay? You don't have to memorize these 2, but put them on your formula sheet, please, okay? So how about we encounter not a secant x squared, but just a secant x itself. What is antiderivative for secant x? It is what? Ln of absolute value of secant x plus tangent x. This is antiderivative, okay? And then plus the constant c, because this integral is indefinite integral, okay? Please put this on your formula sheet. That means later, if you have a secant x integral, just write down this antiderivative directly, this line, this result directly, okay? And how about a tangent x dx? What is tangent x dx? Integral, okay? The antiderivative for tangent x equals Ln absolute value of secant x plus c. We're able to prove this by rewriting tangent x by sine over cosine, and then do it, okay? So you can give it a try, but here I'm not gonna prove it, okay? So remember that, oh, when we have tangent x to the first power, we know the antiderivative is this. When we have a secant x to the first power, oh, antiderivative is this, okay? So now we're ready, okay? Combine these 2 integrals and also these 4 secant x squared, cosecant x squared, tangent times secant, cotangent times cosecant. Okay, so now we are ready to do integrals involving tangent and secant. Okay, so there are 2 cases we need to know. Okay, last time we did what? We did 1 case. Today we'll finish up the other case, okay? But before we look at these 2 specific cases, okay, let's look at how to do question A and B. Okay, for this question A and B, why we talk about them, we don't have to look at these two cases, because for these two cases, okay, they are the integrals of what? A combinations of tangent and secant. Okay, yeah, integration products of tangent and secant is a combination. Then if there's combination, we use these two cases. How about when we have some integrals? They're only of tangent only. There's no secant. Say, we know for tangent x to the first power, this is antiderivative. Now how about tangent x squared? What is the antiderivative? And how about tangent x to the cube? What is antiderivative? What should we do? So let's look at the first case, first question. What is, how can we evaluate this integral? What should we do? Any suggestion? What is antiderivative for tangent x squared? Do we have a direct result? Tangent x squared directly? Yes or no? No, we know secant x squared, right? Yeah, we know secant x squared, antiderivative is tangent. But how about tangent x squared? We don't know. However, we know the relationship between tangent x squared and secant x squared. So what is the relationship between tangent x squared and secant x squared? Tangent x squared equals what? Secant x squared minus 1 dx. We like secant x squared, right? Because secant x squared, we can get an antiderivative, right? So now this is a subtraction. Okay, actually we can split this integral by 2. One is secant x squared dx minus what? 1 times by dx, okay? So what is antiderivative for secant x squared? We just reviewed. What is the antiderivative for secant x squared?
Tangent.
Yes, tangent x. What is antiderivative for 1 with respect to x? X, right? And then don't forget to plus a constant c. Done. You guys, so far so good. Okay, how about we have a tangent x to the cube dx integral. We know tangent x squared can be rewritten by secant x squared minus 1. That's for square. Now we're having a cube. What should we do? Let's still split out as tangent x squared, because eventually we know, oh, we could rewrite it as secant x squared minus 1. And then times by what? Tangent x dx. Okay, can we say this is some derivative, the derivative of something? No, okay. No trig function's derivative equals tangent x. So we're not able to combine these two, okay? So what we do is, we're gonna rewrite tangent x squared by secant x squared minus 1 times by tangent x dx. And then, because these two combined together will not give us a d of something equals tangent x dx. So what we're gonna do is, we're gonna distribute tangent x. So we'll have a secant x squared times tangent of x dx minus integral of tangent of x dx. Now for these two integrals, what is integral for tangent x? Do we have to do anything? No? No, right? Just write down the answer, okay? It's, oh, Ln absolute value of secant x, okay? Then how about the integral of secant x squared times by tangent of x dx? How should we deal with this? We know secant x squared is a derivative of what? tangent, right? So we can rewrite this integral by tangent x times by d of tangent x. What do you think? What do you think? What is the derivative of secant? This is a red. No. Okay, never mind. Okay, never mind. I'll just highlight here, okay? Secant x squared dx is equivalent to d of tangent x. Because tangent of x, the derivative is secant x squared. So derivative of tangent x equals secant x squared times by dx. Okay, okay, so, we're computing tangent x, derivative of tangent x. So what will be the antiderivative from this integral? Still subtract by integral of tangent of x dx. What is antiderivative for tangent of x with respect to tangent of x? 1/2 tangent of x squared, okay? And then this integral is what? Ln absolute value of secant x, then plus constant c. You guys? Yeah, this is hard to understand, okay? If you don't want to use this way, we can do what? By substitution. Let u equals what? Tangent of x. Okay, I'll write it down here, okay? Let u equals tangent of x. So du will equal secant of x squared dx. Okay, so this integral will becomes what? Tangent of x is u. Secant of x squared dx is du. So this integral becomes u times by du. U times du. Yeah, u du. What is the antiderivative for u? 1/2 u squared. U equals what? Tangent of x. So it's 1/2 tangent of x squared. You guys? Yeah, I don't have space to write it down, okay? But if you feel like, oh, this is so hard to understand, you can try to use substitution rule for here and then finish computing this integral, okay? Eventually, you'll still get 1/2 tangent of x squared, okay? All right, so this is a tangent of x to the cube. Any question, concern, opinion? No? All right, then we're gonna look at the combinations of tangent and the secant, okay? So if the power of tangent is m, the power of secant is n, okay? So last time we talked about, if the power of secant is even, okay, if the power of, of secant is even, means n is even, okay? So what we can do is we'll split off a secant x squared, okay? So secant x squared dx, what is it? Secant x squared dx is d of the tangent, okay? Okay, so that's why we'll use substitution for tangent, okay? Yes, let u equals tangent, because du equals secant x squared dx, see? Split off one secant x squared together with dx will give us du eventually. Then we can tell that, secant x squared dx is du, because u is tangent x, so this part will become u to the mth power. And then so this is, everything is in terms of tangent, right? In terms of tangent, right? So secant x to the n minus 2's power, this is n minus 2 is also even. We can rewrite this by 1 plus tangent x squared, then to a power. Then everything will be in terms of tangent, and then tangent is u. So it becomes an integral in terms of u, and then we can finish doing the integral and then eventually substitute u back by tangent of x, okay? So this is when the power of secant is even, okay? All right, so last time we did the question C. I'm not gonna repeat it, okay? So We have two more questions. Okay, two more questions. Let's look at question E here. Okay, question E. Have you noticed that this question, tangent of x to the cube times a secant x to the 6th power dx? Okay, it's a combination of tangent and secant. Have you noticed that the secant of x, the power is what? 6, which is even. Can we use the first method to do the problem? Yes, okay. I'm going to give you several minutes to try this question by yourself as a review for our first method. You may talk to your classmates if you want to, okay? I'll give you 3 to 5 minutes, okay? Yeah, if the power of secant is even, split off 1 secant x squared and use the substitution of u equals tangent of x. Give it a try. You have to practice, okay? Just listen doesn't work. You really have to do it. substitution of tangent and secant. Yeah. So the two cases, the first one, we're splitting the secant x square, right? And then we're going to rewrite this tangent. Oh, use substitution of u equals tangent. Yes, you're right. And then for you, okay, this is secant x square square. So it should be 1 plus 2 yes, you're right. Multiplied by parenthesis 1 plus secant tangent x square square. Because this split out secant x will become d of u.
Oh, so it's 1 secant x. It's 1 secant instead of secant squared.
So this secant x together with dx will become du.
Yeah.
Yeah. So this will be u to the cube times. I don't know where does this adding come from. Yeah. U to the cube times by
1 plus n.
Yeah, that's u. You got it right. Yeah, 1 plus it's u to the and I think it's u, right?
Yes.
1 plus u. You guys not have the calculator already?
Yeah.
All of you go there and then this is 4, right? So u square. You have to bear the microphone, okay? Breathing, okay? And then this secant x dx together becomes 2
So
times u. Okay, we're having Brady tell us how to do the problem, okay?
Oh yeah. So okay, so you have to break it off. And then I always write u equals and du. Okay, and then you substitute it. And you leave the rest the same. So now you can change u for tangent.
We're splitting the secant x squared together with dx, right? Okay, yeah, keep doing that,
Okay. Then you have to plug tangent back in for u. And then add c.
Yeah, you have the right answer. One thing, just one thing. Hello, everyone. Okay, so did you get the same answer as Brady? Everyone? All right, so yeah, Brady did this question 99% correct, but there's one thing, okay, one thing I just want to say, okay, so we're speed of this secant x squared, right? Secant x squared. So the leftover will be this, okay? And then we know secant of x squared dx give us du, right? It's here, okay? Secant x squared dx is du, okay? However, okay, this step, there is a problem. Okay, there is a problem. So here, I would suggest that because these two together give us what? The du, okay, the du. So we'd better to, if you're writing it like this, I would want you to say, let's do the secant of x squared here, okay? Secant of x squared here, and then the fourth power here, okay? So because secant of x squared together with dx, that gives us the du, okay? Yeah, so it's not these two, it's this two anymore, okay? It's this is two. And then this is 1 plus tangent of x squared square. Okay, I know, yeah, you see, you said you write a 1 plus u square, but see, there is a square missing, okay? So it's better to leave the secant of x squared together with dx, okay? So we have a secant of x to the fourth power, okay? Or some of you guys may wrote a tangent of x to the cube times by secant of x to the fourth power, tangent of secant of x to the square dx. And these two give us the du, okay? And then the tangent of x to the cube gave us what? U to the cube. This is from here, correct? Okay. And secant of x to the fourth power is secant of x squared, which is 1 plus tangent of x squared, which good. So this is 1 plus u squared. So just these two, okay, it's like, yeah, not very consistent, okay? But now this step, stuff from this step is no problem, correct? And then we use complete square formula, and then we distribute, give us this. This is u to the 7th, right? And then find antiderivative plus a c here, because once the integral sign is gone, we have to add a c, okay? And then replace u back by tangent of x, okay? So answer is this. Did you get this question correct, everybody? Let me ask you guys.
Yeah.
Yeah, got it? Okay. So I'm having Dominic. Is that Dominic?
Yes.
Oh, okay. So you came in late, so that's why I mark you for absent. Okay. Whoever came in late, let me know. Okay. Otherwise, I will not go back. Okay. Except for I see you in class. Okay. Okay, so that's good for this question E. Okay, no problem, right? Okay, so we practice. That's the first case for tangent and secant. Okay, now guys, let's look at the second case. Okay, the second case is when the power of tangent is odd. Means we may have a tangent of x to the cube, tangent of x to the fifth power. You know, if the power of tangent is odd, okay, what should we do? And there is, okay, a power of secant, okay? So we're gonna split off what? A tangent of x times by secant of x together, okay? The multiplication of tangent and secant. Okay, why we're splitting the tangent times secant? Because we know what? The antiderivative for tangent times secant is what? Secant, okay? So if we let u equal secant of x, okay, du will be tangent x times by secant of x dx. So that's why when we have a power of tangent is odd, we're split off, okay, split off one tangent times secant, because tangent times secant together with dx give us d of what? D of secant. Okay, yeah, so the substitution for this case is let u equals secant x. Okay, then, okay, we're gonna use this relationship and then convert all tangent into secant. Then we do our calculation, okay? So that means, okay, that means once we split out one tangent times secant, this integral becomes what? Tangent of xm minus 1 times by secant of xn minus 1, and then tangent of x times by secant of x dx. So this three, okay, yeah, these three becomes du, okay, if we let u equal secant of x, okay? So when u equals secant of x, so secant of x to the n minus 1's power will be what? U to the n minus 1's power, okay? So this part is u in terms of u. This part is du. And then we only have a tangent of x, okay? Well, the thing is, if m is odd, m minus 1 must even, right? So tangent of x is to the even's power can be written by tangent of x to the square, then to some power. And tangent of x squared can be written by what? Secant of x squared minus 1. Secant of x is u. So we have u squared minus 1 parentheses to the power. Then everything will be in terms of what? U. Okay, I don't have a red pen. If I have red pen, I can rewrite this part for you, okay? So by using this substitution, we can rewrite it in terms of u. If u equals secant of x, okay? So when m is odd. You ready to practice? Okay. You're not practicing. I'm gonna need you to do one problem, okay? Okay, let's look at question D together, guys. We have a tangent of x to the cube. We have a secant of x times dx. Is the power of secant even? We learned two cases, right? For tangent and secant. One case is secant of x is even. Is the power of secant x even? No. Can we use the first case? No. How about the power of tangent is odd? Is it odd? Yes, we do. So what should we do? We're going to split off a tangent of x times by secant of x dx. See, I always split off this thing together with dx, okay? And then if we split off one tangent of x and one secant of x, what's left over? Tangent of x squared, okay? And then do you still remember what is a substitution? Secant of x, okay? So if u equals secant of x, du will be what? Tangent of x, secant of x, dx, okay? See, this part becomes du, okay? Oh, if this is du, how about the tangent of x squared? U is secant. So how can we rewrite this in terms of u or secant of x? We know tangent of x squared can be written by secant of x squared minus 1. Then tangent of x, secant of x, and dx, right? So by the substitution, the integral becomes u squared minus 1. This is what? Du. Whew, so simple after we substitute, right? So what is antiderivative for u squared and then negative 1? We should get what? 1/3 u to the cube minus what? U plus c, right? So what is u? Which is 1/3 secant of x to the cube minus secant of x plus what? C. Done. Okay, let's just remember, secant of x is even. I can use first case. Tangent of x, power is odd. Use the second case. All right, guys, now let's go back to the question E. Just now, I let you practice that when secant of x is even, right? We split off the secant x squared, remember just now? Now let's check. What is the power of tangent? Is it odd? Yes. This means for this question, we can use what? Both methods, okay? So I'm going to lead you to redo question E by using the case of what? If the power of tangent is odd, and see whether we have the same answer or not, okay? So I'm gonna use another script paper. Okay, question E. There we go. If the power of tangent is odd, what should we do? Split out what? Tangent times secant, right? So, a tangent of x times by a secant of x dx. Okay, split out one tangent, one secant. So what will be the leftover? 1 is gone. square left, right? And then 1 secant is gone, so we should have what? Secant x to the fifth. You guys? All right, so what substitution should we do? Same thing, that u equals secant of x. So du will be what? Tangent of x times by secant of x dx, because the derivative of secant equals tangent times by secant. So you know, oh, this part is du. This part becomes what? U to the fifth. And how about tangent of x squared? Tangent of x squared can be written by what? Secant of x squared minus 1. Can we? I'm gonna write, I will not write another line, okay? Just want to let you know, oh, tangent of x squared can be written by secant of x squared minus 1. So by using the substitution, what can we rewrite this line by? U squared what? Minus 1, yes. Secant of x to the fifth, u to the fifth, du. Very good. Oh, I feel so happy. You guys really understand, okay? Understand it. All right, so what do we do now? Distribute. Why there were 3 terms just now? Did I miss anything? No, I don't think so. 1, 6. Let's see. No. Du, okay? So this is u to the 7th minus u to the 5th du. Hold on 1 second. Let me see, what did I do? Tangent of x. Yeah. Oh, I see. Because we're using different trig. We're good, okay? We're good so far, okay? We're good so far. So this is u to the 7th minus u to the 5th, right? So what will be the antiderivative? 1 over 8 u to the 8th minus 1 over 6 u to the 6th plus 1. Constant c, right? And then don't forget to substitute u back by what? Secant of x, okay? So we're getting 1/8 secant of x to the s minus 1 over 6 secant of x to the 6 plus 1, a constant c, okay? Okay, guys, you may ask, oh, if we're using this method to do the question E, this is the result, okay? And just now, this is the answer we get. Oh, it has 3 terms, right? But here it only have 2 terms, okay? They are the same, okay? It looks very different, but they are the same. Why? Because one is in terms of what? Tangent. The other one is in terms of what? Secant. For secant, you know, in terms of sin and cosine, we know secant of x equals 1 over cosine, right? But for tangent, it equals what? 1 over sin of x over cosine of x. So if you have time and you're interested to prove this line equals this line, go ahead to do so. However, I want to let you know that, yeah, we can prove them later that they are the same. They look different, but they are the same. Why? Because these two, tangent of x and secant of x, they are 2 different trig functions, but they equal, okay? Because, you know, by using sin and cosine, okay, we can simplify, okay, like combine, and also using trig identities, okay? They look different, but they're both correct, okay? So in your exam, I'm not going to ask you, oh, you're gonna use the first case where, you know, use the method by second case. You can use either, okay? Even if your answer looks different, they're both correct, okay? They are, okay? All right, so this is second part from section 7.2 about product, okay? Integrals involving tangent and secant. So we know, okay, if the integral only involves about a tangent of x, okay, see first power, second power, third power, how to do them. And then secant of x, the first power is this, okay? What is a secant of x squared? What is a square? This is easy, right? Tangent of x plus c, okay, we did those, okay? only involves tangent or secant. Also, we did, oh, if we combined with, okay, tangent and secant, what are the two cases? Okay, so this is about the second part. Everybody clear? Okay, I think you're ready to practice by doing your homework assignments. Okay, all right, so this is section 7.2. Any question from section 7.2? All right, then let's move on to section 7.3. Okay, yeah, section 7.3. If you get the idea, you feel this is not that hard, but what you don't get the idea, you still feel this is a challenging section. Okay, so section 7.3, we're still involving trigonometric, integrals, okay? Substitution, okay? So we are going to evaluate integrals involving what? Radical expressions, okay? See, in this section, we will see how to evaluate the integrals containing radicals, okay? So the integrals has no trig shows up directly. See, no trig. However, to solve this type of the, integrals involving radical, we have to use trig substitution. Okay, so in your exam 1, you don't have to worry about, oh, for this question, what kind of method should I use? I will let you know very clearly that please evaluate these integrals by using substitution rule, by using integration by parts, by using trigonometry, okay, by using trig substitution, radical expression. You know directly for solving each type of the integrals what method you are going to use. You don't have to worry about, oh, there's so many rules. What rule should I choose? I will let you know for sure. Oh, let's do these questions by using this method, do those questions by using those methods, okay? What you're gonna know is, you're gonna prepare is from each section, oh, this question, I'm gonna use a trig substitution to do it. Remember the specific case and then apply to the specific case. That's it, okay? So hopefully that helps you, okay, to prepare for your exam, okay? All right, see, all of these integrals we'll encounter from this section, they're with radicals. You may see, oh, there's no radical from this question. 3 halves in something's 3 halves means what? What is that? Square root of x to the cube. So still a radical, okay? This is radical integral. There's a third question. We're gonna look at 3 questions, 3 cases. See this one? Radicals, okay? Yeah, so this type of the integral, how can we use trig substitution to do it? Okay, let's look at all of the 3 cases one by one, okay? We have about another 50 minutes. I hope I can cover all of the 3 questions, hopefully, okay? So the formula table, I would strongly suggest you put this on your formula sheet, okay? Yeah, you may ask, oh, there's so many. You can write your letters, smaller until you can see them clearly, okay? So put them on your formula sheet, okay? All right. So expressions in the integrand, okay, this formula table is important, okay. We have to choose a corresponding substitution for each different types of the radicals, okay, because for different radicals, if we use different substitution, that may not work, okay, it may not work. It has to be for different integrand, okay, radicals, we have the corresponding substitution. So let's look at the first case, okay. If we encounter a radical, okay, under the radical, we are having a squared minus x squared. A is a constant, okay? Yeah, so we encounter, oh, a square root of a squared minus x squared. Then the corresponding substitution will be x equals a times by sin of theta, okay? So that means later, oh, I want to replace x by what? A, which is a constant, we figure out the constant, okay? Times by sin of theta, okay? So previously, what is a variable? X. A is a constant. After the substitution, what will be the new variable? Theta, okay? So trig substitution, we are substitute from, we use trig function to do substitution, and we're going to change from the original variable x in terms of what? Angle theta. Okay, all right, so now let's look at this case. If x equals a times sin of theta, Okay, so what will be the derivative of x? Because for integrals, we always have to do d of x, right? d of x. So what is dx for x equals a times sin theta? A is a constant. Derivative will be what? A times by what? Cosine theta d theta. Okay, if x equals a times sin theta, dx will be a times cosine theta d theta, right? All right, and because now we're changing from x to theta, okay, so we know d of x, okay, so we have to rewrite this radical in terms of theta. How? This is a simplification, guys. A squared is still a squared minus, if x squared equals a times sin theta, x squared should be a squared times by sin of theta squared, right? So a squared is a common factor, pull it out, square root of equals a squared times 1 minus sin of theta squared, right? Yeah, a squared is a common factor, right? So what is 1 minus sin theta squared? Cosine theta squared, right? So square root of a squared times cosine theta squared, square root cancel out, give us what? Offset, give us a times 1, cosine theta. Oh, so that means if we use this substitution, this radical expression will become what? A times by cosine theta. There's no x anymore. It becomes a what? Theta. Okay, and then dx is also in terms of theta, so this entire integral will becomes what? Theta. Then we find the antiderivative in terms of theta and change theta back in terms of what? X. Okay, so let's look at question A. Okay, question A. Well, here, I still want to talk more about this x equals a times sin theta. Okay, so if x equals a times sin theta, divide by a from both sides, sin of theta equals x divided by a, right? So if we draw a right triangle, you'd better draw this right triangle on the side to later help you digest. Yeah, write it down on your notes, okay? So assume this angle is theta. I'm asking you, sin of theta is which side divided by which side? We have three sides: the opposite side of theta, adjacent side of theta, hypotenuse. So sin of theta equals which side over which side? Opposite divided by what? Hypotenuse. Yes, very good. Okay, now our sin of theta equals x over a. So we just let this opposite side is x, and then the hypotenuse is a. So x over a equals sin of theta. Now, by using Pythagorean theorem, what is the length of this side? We know the square of this side plus the square of this side equals a squared, right? So this side can be written by what? Square root of what? A squared minus what? X squared. Right, John? Pythagorean theorem, right? Pythagorean theorem, right? So a squared minus x squared and square root give us the length of this side. And then this is a what? The radical, okay, shows up in the question. If we have a squared minus x squared, the constant is in front and minus than x squared, okay? So that's why if we have a radical looks like this, we're using this substitution by using sin, okay? All right, now let's look at the specific question. How do we find this integral? Now let's check the radical. Which case? Case 1, 2, and 3. Which case? The first one, okay? The first one. And then what is a value? 3. Yes, you're right. We're right. Oh, a equals 3. So what substitution should we do? What substitution should we do? We're going to let x equals what? A times sin theta. What is A? What is A? 3, right? This is a key for the question. Make sure what case it is, figure out what is A, and then let x equals A times by sin theta. Okay? All right, guys. Once we know x, okay, oh, we know that later we can rewrite x in terms of 3 sin theta. We can rewrite the radical expression. We can replace this x by 3 times sin theta. Don't forget to do the derivative, right? What is dx? 3 times cosine theta, right? D theta. Okay. Oh, so we know dx will becomes of this. Okay, x will becomes of this square. However, we also have to compute the square root, right? So I'm gonna just do it directly. Okay, here equals square root of 3 square minus what? 3 times sin of theta square. 3 square sin of theta square. Okay, divide by 1. X square. 3 square sin of theta square. Okay, right? Am I right? This is square. Times by dx. What is dx? 3 cosine theta d theta. We are very happy. No x anymore, just trig. Even if I know most of you guys, you don't, trig is not, yeah, right? You don't, I know, not everybody like trig function, but so far, let's see. When we simplify it, it may become a very nice trig integral, okay? So what is square root of 3 square minus 3 square sin theta square? What is it? Pull the 3 square out, right? 1 minus sin square give us what? Cosine theta square. Divide by, this is still 3 square, which is 9. Or 3 square, we can keep it. Sin of theta square times by 3 cosine theta d theta. Isn't this nice? 3 square cosine theta square square root. It becomes what? 3 cosine theta. I'm gonna put this 3 cosine theta on the top because it's over 1, right? Times by 3 cosine theta, which is 3 square cosine theta square. 3 square sin of theta square d theta. You guys know why we have a 3 square cosine theta? One comes from the square root. The other one comes from here. When we multiply, 3 square cosine theta square. And then 3 square sin theta square. What is cosine theta square over sin theta square? Is it tangent? Cotangent, right? Cotangent. Okay. Well, cotangent theta square, do we have antiderivative? Cotangent and cotangent theta square. This is cosecant. This is secant, right? We like secant cosecant square, right? But how about cotangent? There's no cotangent, right? There's no cotangent theta square, okay? So here, okay, either you can write it as cotangent theta square, but eventually we have to still split, okay, split. Okay, let's do it this way, okay? So cotangent theta square, there's some other different ways to do it, okay? Cotangent theta square, there's no antiderivative. But cotangent theta square, we can rewrite this in terms of what is the trig identity for cotangent and the cosecant? Because we want cosecant square. There's no, right? Okay, cotangent equals what? Equals cosine divided by sin, and cosecant equals what? Theta equals 1 over what? Sin of theta. So I want to say that the cosecant of theta squared equals cotangent of theta squared plus 1 or minus 1. Yeah, this is something that we want to prove. Very likely this is minus 1, right? Because this is cosine theta squared over sin of theta squared. Oh, okay. Minus 1 is better. Minus sin of theta squared. Oh, plus 1. Let's do plus 1. Yeah, plus 1. There we go. We need this identity, okay? Yeah, there, identity. Just like a secant and the tangent, okay? Secant theta squared equals tangent theta squared plus 1. Now for cosecant, same thing, okay? Cosecant theta squared can be written by cotangent theta squared plus 1. Yeah, this is plus, okay? So cotangent theta squared can be written by cosecant minus 1, okay? Why we're doing this? Because for cosecant theta, do we have antiderivative? We do? Yes or no? Negative cotangent, okay? So 1, negative 1, antiderivative with respect to theta. This is theta, and then plus what? Constant c. Ooh, can we say we're done for the question? Can we say we're done? This is 7.2, right? Yes or no? No. Why? What was the original variable? What is a new variable? Theta. We always know that for what? Substitution. We have to change theta back in terms of x, right? However, for trig substitution, there's something that we have to know is by using this triangle. So that's why, see, you understand that we have to use a substitution to change theta in terms of x back, okay? Well, the thing is, how? I'm gonna rewrite it here, okay? So x equals 3 times sin of theta, okay? So sin of theta should equals x over 3, right? Draw the same triangle, okay? If theta's here, sin of theta equals opposite side divided by hypotenuse. Opposite side is x, hypotenuse is 3. So adjacent side should equals what? Square root of what? 3 squared, which is 9, minus x squared. You guys, we always have to make sure we know the 3 sides, because eventually this answer may not be sin of x, it may be something else. So now I'm asking you, what is cotangent theta by using the 3 sides? You remember cotangent? If this is theta, tangent should be opposite divided by adjacent. So cotangent is what? Adjacent divided by what? Opposite. Yes. So, oh, how to rewrite cotangent theta back? Adjacent side divided by opposite side. Square root of 9 minus x squared divided by what? X. You guys. Oh, this is cotangent theta. That's good. How about theta? I don't know how to, rewrite theta in terms of x. So what should we do? If sin of theta equals x over 3, theta will equals inverse sin of x over 3. Do you agree with me? Right? We want to replace theta in terms of x. Since theta equals x over 3, theta will be inverse sin of x over 3. So minus inverse sin of x over 3. Now how about this? Looks pretty because they're only in terms of x, right? Done. Trig substitution. First the case. Guys, if we summarize this question, what should we do for this trig substitution question? First, identify what case it is, right? And then use corresponding substitution. Then do calculations, rewrite the previous integral in terms of what? Simplify, blah, 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 in terms of a new integral in terms of trig. Find the antiderivative, then back substitution by using the right triangle. What do you feel? It's okay, right? All right, so this is the first case. Any question from the, from you guys who are, any question? Were you good? Are you good? Are you good with this first case? Everyone? Can you follow me, everyone? Okay, all right, so this is the first case. Similarly, okay, they're not the same thing, but yeah, all of the, if you understand the first one, the rest two are, we're just repeating, not exactly the same technique, but a similar technique about substitute by using trig and then change trig angle back into our x, okay? Second case, if we're having a squared plus x squared, so what substitution should we use? A squared plus x squared. We're going to let x equals what? A times tangent. Why? Because we want to get rid of the absolute, not absolute value, want to get rid of the radicals, right? So if we replace x by what? A times tangent. When we put the a squared out, we'll have a 1 plus tangent theta square. What is 1 plus tangent theta square? Secant theta square, right? So a squared secant theta square square root. Get rid of the radical, we'll have a times sin theta. Do you see that? Okay, and then the derivative of x in this case is what? What is the derivative of a times tangent theta? Tangent theta, derivative. What is the derivative for tangent? Anyone know? Secant theta square, okay? Yeah, and then d theta, of course. Okay. Third case, it has to be x squared minus a squared, okay? If this is the case, we use a times secant theta as a substitution, okay? And then when we replace x by a times sin theta, we'll have a squared times sin theta square. Put the a squared out, we have a secant theta square minus 1. That's going to be tangent theta square. Get rid of the radical, a tangent theta. Now, what is the derivative for a times secant theta? What is it? Tangent theta times what? Secant theta d theta, right? All right, we're ready, okay? There's no other new materials. All of new materials are here, and then we're ready to practice. What's up? A is always hypotenuse. No, not always. In this case, A is hypotenuse. And you will see in this case, A may not be the hypotenuse. A may be just one side, maybe a leg of the right triangle. So it really depends on the substitution. So you will see this one, A is not the hypotenuse. No, okay. Yeah, so very good question, okay? Okay, so now let's look at a question involving the second case. This integral, this is a definite integral. We have to be very careful. A squared plus x squared. What is this? 3/2. Three halves means cubes, then roots, right? You agree with me, right? A squared plus x squared, then cube, then root, right? Square root. Okay, where this a is greater than 0. Okay, definite integral, careful. So what case it is? I just told you. Okay. Now what's the difference between these two cases? This must be x squared minus a squared. This first case must be a squared minus x squared. This one is a sum. You have to be specific, okay? Yeah, because for each case, we have to use a certain substitution. So this case is when a squared plus x squared, we use what substitution? X equals what? Tangent, okay? X equals a equals tangent, okay? So for this question, we're gonna use a equals what? Tangent theta. So, oh, sorry, x equals a times tangent theta, sorry. Okay, x equals a times tangent theta. So dx should equals what? We just did it, right? A times by secant of theta squared d theta, right? So later, oh, dx will becomes this. Now let's compute the square root, okay? You can do it directly or you can compute it separately. A squared plus x squared to the cube square root becomes what? A squared plus x squared. A squared tangent theta squared cube a squared. I'm going to write it here directly. 1 plus tangent theta squared is secant theta squared, then cube. Okay. Now we have square, cube, then square root. Okay. So this can be written by what? See, this radical can be written by cube square root, or it can be written by what? Square root of x cube. Either way, okay? So now we can do what? Square root of a squared times secant theta squared, right? That gives us a times secant theta. Then to the cube. Right? So what is this? This is the bottom of the integral, okay? And then dx is a secant theta d theta. Okay, so we can replace those two. Okay, well, the thing is, for definite integral, when we do substitution, we always have to what? Refigure out the limits, okay? So how can we refigure out the limits? These limits are for x. We need the limits for theta eventually. So by using this substitution, when x equals 0, when x equals 0, when x equals 0, 0 equals a times tangent theta, theta will equals what? Tangent theta must be 0, right? So tangent theta equals 0, theta will be what? 0. Okay. So when x equals a, this substitution becomes a equals a times tangent theta. Okay. And then if a is positive, we may divide a from both sides. Oh, so this one implies what? Tangent theta equals 1. Right? Yeah, we're also dividing a from both sides. So 0 divided a is 0. So theta equals, tangent theta equals 0, theta equals 0. So what angle satisfies tangent of this angle equals 1?
Pi over 4.
Very good. Thank you. When theta equals pi over 4, tangent of pi over 4 equals 1. So, so these two will be the new limits for theta, right? So 0 to pi over 4. Okay. So dx A secant theta square d theta. And then this bottom is what? A to the cube, secant theta to the cube. Right, guys? All right, so A, and then this A to the cube give us A square, which is 1 over A square, which is constant. Okay, secant theta square cancel out. We only have a sin of theta, secant of theta, right? Okay, so this integral can be rewritten by 1 over A square, 0 to pi over 4, 1 over secant theta d theta, right? What is secant of theta in terms of sin or cosine? What is secant of theta? 1 over cosine, right? So 1 over cosine becomes what? Wow. After the substitution, this integrand is very simple. Cosine theta, right? What is antiderivative for cosine? Sin of theta. But don't forget that we have to evaluate the sin theta from 0 to pi over 4, right? And then 1 over A squared, which is constant. Okay. Sin of pi fourth minus sin of 0. We don't need to use a bracket, just a parenthesis should be enough. Eventually, how about you tell me the answer? Sin of pi over 4 equals?
Square root of 2 over 2.
Yeah, square root 2 over 2. And then times by 1 over A squared. Answer is going to be square root of 2 over 2 times A squared. Okay, for this question, do we have to change, theta back in terms of x or anything? Do we have theta anymore? No. Why? Why there's no theta? Because it's a definite integral. Okay, so we don't have to change theta back. Okay, but for indefinite integral, the answer will be a function in terms of theta, right? We have to change theta back in terms of x. Okay. All right, so this is the second case, okay? Now let's look at our last question, okay? Last question. Yeah, integral of square root of x squared minus 9 divided by x to the cube dx. What case it is? Yeah, third case, right? Square root of x squared minus a squared. So we have to use what substitution? X equals a times by secant theta. Okay, what is a? 3. Okay, so let x equals 3 secant theta. Okay, so dx will be 3 tangent theta times by secant theta d theta. You agree with me? Okay, now let's compute. Yeah, I think we can do it directly, okay? Because on the top is just we replace x by 3 secant theta, and then let's do it directly, okay? So integral will becomes square root of 3 secant theta square minus, x square means 3 square secant theta square minus 9 divided by 3 to the cube. X to the cube means 3 to the cube, secant theta to the cube, and dx is what? 3 tangent theta, secant theta, d theta. Okay, here. 3 square or 9, which is 9, we can pull it out. Okay, yeah, we can pull in front of the secant theta square minus 1. Secant square minus 1 is tangent theta square, right? So this is square root of 9 times tangent theta square divided by, I would say this is 3 to the cube, secant theta to the cube. I'm going to write this on the top. Okay, on the numerator, that gives us the 3 tangent theta secant theta d theta. Okay, so this is what? Okay, there we go. Okay, get rid of the radical, give us what? 3 times tangent of theta. Together with this 3 tangent theta, so we have a 3 square tangent theta square secant theta divided by 3 to the cube secant theta to the cube d theta. This radical gives us 3 tangent theta. Together with this one, 3 square tangent theta square times secant 3 to the cube secant theta to the cube. Can we do some simplification? Ooh, just 1/3 left. Secant theta to the cube, secant theta square. You guys? All right, now we're having this 1/3, right? And then tangent theta square over secant theta square. What should we do, guys? When we want to find the antiderivative, do we want to keep secant tangent theta square, or do we want a secant theta square show up? Which square give us antiderivative directly? Secant theta square. So if we both show up, we want to replace this tangent in terms of secant, right? So it's going to be 1/3. Okay, secant theta square minus 1 over secant theta square d theta. Okay. Yeah, all right. So this is 1/3. Secant over secant is what? 1 minus, what's 1 over secant? Yeah, I'm gonna write for one more step because I don't want some of you guys confused. Oh, why we are doing this? Okay, we'll still get the same answer, but I see a shortcut there. Tangent theta can be written by here. What? This is 1/3. Sin theta square over what? Cosine theta square. What's secant theta square? 1 over cosine theta square, right? D theta. So cosine theta square are both on the bottom, cancel out. So this will give us 1/3 sin of theta square d theta. See? But you will see eventually, if we do it this way, getting the same answer, okay? Why? Because this is 1 over cosine theta square d theta, 1/3, 1 minus 1 over, you know, flip up cosine theta square d theta. And then this is the same thing. I did the same, right? Yeah. So either you do it this way, this is not the best way. Best way is to write tangent in terms of sin over cosine. Right? Secant by 1 over cosine. So cosine theta square cancel out. That gives us the sin theta square directly. But sometimes, you know, if we don't try, we don't know which one is the best. Okay, so we're here 1/3 sin of theta square d theta. We're not done for even the antiderivative. So how to find antiderivative for sin of theta square? We learned from section 7.2. Heck, when we are having sin and cosine, oh, the powers of sin and cosine. See, if n is odd, if m is odd, you know, we use this method. How about when the powers of sin and cosine, they're even? What should we do? sin of x squared reduced, right, by using the double angle formula, right? Okay, so 1/3 times 1/2, 1/6, 1 minus cosine of 2 theta d theta. Do you know why we have a 1/6 here? Because a double angle formula, we have 1/2, right? 1/2 times by 1/3 gives us 1/6. Okay. Now, antiderivative 1/6 theta minus what? D of 2 theta, 1/2, right? 1/2 sin of 2 theta plus constant c. Okay, or if you want to distribute the coefficient, that give us this, right? All right, can we say this is completely done? No, we always have to use a substitution, create a right triangle, and then find a relationship between theta and x, right? And then substitute theta back in terms of x. So secant theta equals x over 3. Secant theta equals x over 3. So secant theta is which side over which side? Yeah. So we know cosine is what? Yeah. So cosine is adjacent over hypotenuse. But 1 over cosine, hypotenuse over what? Adjacent. So x is hypotenuse, 3 is what? Adjacent. By using Pythagorean theorem, what is the length of this side? Square root of x squared minus what? 3 squared, which is what? 9. Right? All right, so let's see what we're gonna have here, okay? Here. For this theta, okay, it's easy because if tangent, secant theta equals x over 3, theta should equals what? Inverse secant of x over 3. It's always like this, okay? If the angle itself, okay, theta equals inverse secant of x over 3. Now, we talk about sin of 2 theta. This is just one sin of 1 theta. So sin of 2 theta, what should we do? If sin theta times cosine theta equals 1/2, sin of 2 theta. Sin of 2 theta must equal what? Double of sin times by cosine, right? Multiply by 2 from both sides. Sin of 2 theta equals 2 times sin times cosine, right? So this one becomes 2 times sin theta times cosine theta. So we have a negative 1/12 times by 2, which is negative 1 over 6. Okay. 1/12 times by 2, 1 over 6. Sin of theta. What is sin of theta? Opposite side divided by hypotenuse, right? Times by cosine theta. What is cosine theta? Adjacent side divided by what? Hypotenuse, right? 3 over x. You guys agree with me? This is not easy, okay? Not easy. And then plus the constant c. Okay. All right, now let's simplify. This term, no way to simplify in terms of x, good. 1/6 and then 3. 2, right? Half, 1/2. This x times by x, I'm going to rewrite it in another line. 1 over 6. Secant inverse of x over 3 minus 1/2. X times x give us what? X squared. Okay, so this is 1/2 times by square root divided by x squared plus what? C. All right. So these are all of the 3 cases. Okay, so be prepared in your exam. Okay, I'll let you know. Do this question by using the trig substitution, but you have to know which case and what substitution we're going to use. And eventually be able to substitute theta back in terms of x if the integral is indefinite. If we have a definite integral, we'll have a constant as our results. Okay. All right, so for section, now we finished section 7.2 and 7.3. Okay, so see both sections we're using trig a lot, right? Please do review for these sections. All of the sections we have learned, because our exam will be due by in 10 days, right? Yeah, okay. So this Wednesday, right? Monday, we'll get section 7.4 done. Wednesday, yeah, you guys ask questions if you have. Then Monday after next week, due date for the first exam. Okay? If you have not scheduled your exam in the testing center yet, please make sure you schedule an appointment and then make sure that by February 10th, you have a spot to take your first exam. Okay? All right, guys, that's quite a day. Okay? If you have any questions, shoot me an email or contact me. Okay? Yeah.